Okay. Next problem is of determine the Z transform. Here x of n, it is given as alpha raised to n u of n plus beta raised to n u of n, and they are given the condition that alpha is less than beta. As usual, what we solve the problems, the steps what it's going to be, here also we are following the same steps. Here given equation you have to write first, then we have to find the Z transform. For that reason, write the equation of our Z transform, that is x of z is equals to summation n varying from minus into plus infinity x of n z raised to minus n. Then what is our x of n? It is of alpha raised to n u of n plus beta raised to n u of n. That you have to take. Observe before first you have to substitute that. After substitution, observe here alpha is less than beta, means the alpha values where it is going to be existing, it is in the left half side, and beta values what's going to be existing, it is at the left half side, right half side. For that reason, the limitation is going to be varying from minus infinity to 0. There you will be getting of your alpha values, alpha raised to n u of n z raised to minus n, plus where the positive values in the right half of side of the x plane, like if I divide the x plane means z plane from 0 to infinity and 0 to minus infinity, this part it's going to be existing your alpha part, and this part your beta values are going to be existing. That's what the, from this equation you have to find that. Therefore, next n, where n is varying from 0 to infinity, our beta is going to be existing, that is of beta raised to n u of n z raised to minus n. Then we have to change the limit because we don't have the equation, so that we can go to minus infinity to 0 range. For that reason, here for negative values of beta, minus summation n varying from 0 to infinity, power is going to be changing. Observe here negative values, and also the power is going to be changing because of when limit is going to be changing. For that reason, u of n is giving the values 0 to infinity, but in the negative values. Understanding what I am going to tell for you all? Alpha raised to, instead of n it's going to be minus n, z raised to, instead of minus n it's going to be n. Here as usual, u of n is going to be 1 only. For that reason, n summation n varying from 0 to infinity, beta raised to n z raised to minus n. Then write the equation in terms of the whole power, that is alpha raised to minus n into z power n, taken power as a common. Here also the same thing we done. Then use the equation, already we come across the equation, that is nothing but you will be getting as minus 1 divided by 1 minus alpha raised to n, alpha raised to minus 1 into z, plus 1 divided by 1 minus beta into z inverse. Then solve for this, take the LCM and multiply, cross multiply with the numerator values, then you will be getting the equation like this. Again solve for this, you will be getting as beta by z minus z by alpha divided by 1 minus alpha raised to minus 1 z, 1 minus beta into z raised to minus 1. Then if you find if you are going to find a region of convergence, just you have to go with using this equation. Based on this equation, I already stressed why you have to take this equation only, right? That is nothing but alpha raised to minus 1 into z is less than 1, then beta z inverse is less than 1. Then this alpha raised to minus 1 I can write as 1 divided by alpha. Therefore, mod of z is less than alpha, and here I can write z inverse as 1 by z, and this z is going to be this side. Therefore, mod of beta is less than mod of z. From this, our z is going to be existing, where it is going to be existing, here z is greater, means here it's going to be beta, here it's going to be alpha, right? Based on that, concentric ring will come alpha, here beta, and our region of convergence is going to be existing in between of alpha and beta, that is here. This is also important. This will be asking in the 6 marks or else 8 marks in the exam. It's like a general problem, okay? Then the next problem is of determine the Z transform of the signal x of n is equals to 1, 2, minus 1 and 1. 1 is going to be existing at n is equals to minus 1 and 2 is going to be existing at n is equals to 0 and minus 1 when at n is equals to 1 and at n is equals to 2 you'll be getting as 1 and for otherwise you will be getting as 0. Based on the given equation, first you draw the how you will be getting this is discrete time signal. Yes, for that reason only we will be applying our Z transform. Based on that, first you write the graph what you will be getting. So at minus 1 you will be getting as 1. This is one sample. At 0 you will be getting as 2. This is one more sample. At 1 again 1 you will be getting as minus 1. At 2 you will be getting as 1. For other cases it will be 0. This is what how you have to draw the graph. Then use the equation our Z transform x of z is equals to summation n varying from minus infinity to plus infinity. Then where is our signals are going to be existing from minus 1 to 2. For that reason n is varying from minus 1 to 2 x of n z raised to minus n. Then expand this equation for n varying from minus 1 to 2 x of minus 1 z raised to 1 minus of minus is going to be plus. Then x of next value is x of 0 z raised to 0 plus x of 1 z raised to minus 1 plus x of 2 z raised to minus 2. Then solve for this. What is our x of minus 1 is how? X of minus 1 is of 1. Substituting that as 1. Then x of 0 is of x of 0 value is of 2 that you have to write here. Z raised to 0 is 1. Then x of 1 is minus 1. Then x of 2 is 1. Z raised to minus 2. Then you solve for this. You will be getting as x of z is equals to z plus 2 minus z inverse plus z raised to minus 2. This is what the Z transform equation for the given x of n. Then next problem is of find the Z transform of the sequence x of n is equal to 1 by 3 power n sine pi by 4 into n u of n and check the region of convergence and also pole 0 location for this problem. If they are asking the pole 0 equation means that question will be for 8 marks. Okay, then solution is going to be first you write the given equation and then what is the sine function? Sine in terms of your exponential terms, that is 1 by 3 power n. Instead of sine pi by 4 n I can write as e raised to j pi by 4 n minus e raised to minus j pi by 4 n divided by 2j into u of n. Then multiplying 1 by 3 power n to the both the parameters, that is e power plus j and also for the minus j, and then again u of n is also multiplying for the both. Then I'll be getting as 1 by 3 power n e raised to j pi by 4 n divided by 2j into u of n minus 1 divided by 3 power n e raised to minus j pi by 4 n divided by 2j u of n. Then this 1 by 2j is taken outside. Then here 1 by 3 power n is there, that this whole power, it is written here. Therefore, e raised to j pi by 4 divided by 3 whole power n u of n I can write minus 1 divided by 2j e power minus j pi by 4 divided by 3 the whole power n u of n. Then I am using of my z transform equation. Here we resolve the equation what it is given. After resolving that, you have to substitute in the given equation in the z transform equation. That is x of z is equals to summation n varying from minus infinity to plus infinity x of n z raised to minus n. Here we will be substituting for x of n now. Observe here, substituted the equation of this here into z raised to minus n. Then this summation for both the terms. Then summation n is varying because here varying from 0 to infinity because of u of n function. Directly it is written here 1 by 2j e power j pi by 4 divided by 3 power n z raised to minus n minus summation n varying from 0 to infinity 1 divided by 2j e raised to minus j pi by 4 by 3 whole n into z raised to minus n. After this, by using of the formula, you substitute and you will be getting as 1 divided by 2j 1 divided by 1 minus e raised to j pi by 4 divided by 3 z inverse. Here in the same way, minus 1 by 2j 1 divided by 1 minus e raised to minus j pi by 4 divided by 3 z raised to minus 1 you will be getting off. Then this 1 by 2j it's taken commonly. Observe here, here it is written. Then take the LCM and cross multiplication you do. Then you will be getting as 1 minus e raised to minus j pi by 4 by 3 z inverse minus this written as it is 1 minus e raised to j pi by 4 by 3 z inverse. This is the LCM equation what we taken. Then multiply with each elements and solve for that. Go on solving and you will be getting as e raised to j pi by 4 divided by 3 z inverse plus e raised to minus j pi by 4 by 3 z inverse divided by the denominator part as it is you will be getting. After this, you have to go for using of the e raised to j pi by 4 what I can write sin cos pi by 4 minus j sin pi by 4. Based on that, substitute the equation, then you will be getting as, and again what is cos pi by 4 sin pi by 4, you substitute those values, then you will be getting as 1 divided by 3 this 1 by 3 as it is, then root 2 divided by 2 z inverse plus 1 by 3 root 2 divided by 2 z inverse cos pi by 4. That equation you have to go for. Then again solve for this. If you solve, and you will be getting as root 2 by 3 z inverse into j divided by 2j 1 minus this is the numerator part denominator part as it is. Here I didn't change anywhere, just taken the LCM and keeping as it is going on. J get cancels, then you will be getting as solve for this, then you will be getting as 1 divided by 3 into root 2 z inverse divided by 1 minus e raised to j pi by 4 divided by 3 z inverse 1 minus e raised to minus j pi by 4 divided by 3 z inverse you will be getting off. This is what the equation you will got. Then this z inverse I can write as 1 divided by z, right? Here also 1 by z I can write, here also 1 by z I can write. Then take the LCM and go for the simplification. Then you will be getting as 1 divided by 3 into root 2 z divided by z minus e raised to j pi by 4 by 3 into z minus e raised to minus j pi by 4 divided by 3. Then both sum should converge, means based on the equation where you have to go, you have to check here. After substituting, what you will be getting, that is e raised to j pi by 4 divided by 3 into z inverse is less than 1 is less than 1. Then e raised to minus j pi by 4 divided by 3, z inverse is again less than 1. Okay, based on this, just you observe here, both the z inverse, it's almost same, only the e power here plus j pi by 4, here minus j pi by 4 is there. That's the difference. Therefore, what is the mod of z is going to be existing for the, in terms of this value, it is giving the information for us. It is about the magnitude part. From this e power factor, what it is giving, e power j theta I can write, right? E power j theta, z is nothing but, based on that, this pi by 4 is nothing but our theta value. Okay, that is the angle, that is angle is going to be pi by 4. Therefore, mod of z is greater than 1 by 3. Means z inverse I can write as 1 by z, 1 by 3, right? Therefore, if I less than 1 means mod of z 1 by 3 less than z. You will be getting off. The same thing I written here. Means the unit circle, what it is going to be, it's the radius is of 1 by 3. And the angle here plus pi by 4, here minus pi by 4. This is what the angle it's going to be intersecting here. And okay, this is the circle what you have to go for. Then that is the with 1 by 3 magnitude. Then where is our region of convergence is going to be existing? Mod of z is greater than 1 by 3. Means outside the circle. That's what here it is drawn. Here it will be existing. Then after this, what they asked for us, we have to find what are all the poles and zeros location, right? For that reason, what you have to do, we have, after solving the equation, should be in terms of z. It should not be in terms of z inverse. It should be in terms of z, right? The numerator equation, numerical characteristic equation should be equals to 0 and denominator characteristic equation should be 0. Then I will be getting as the numerator part, it will be giving the number of zeros, and denominator part, it will be giving the number of poles. Z is equals to 0 means at origin you will be getting 1, 0. It is represented as, it's a small circle. Then when I equate the denominator part is equals to 0, you will be getting as z is equals to e power j pi by 4 divided by 3. Again here also e power minus j pi by 4 by 3. Means where the angle and also my circle radius is going to be touching each other or joining the value, that there you will be getting as the poles, that is represented as a cross mark for the poles. Here it is shown. Two poles are going to be existing. This is how you should solve this problem. This is very important. If it is, this problem is asking almost, it will be asking for 8 marks, or else they may ask for 6 marks. This is lengthy, but you have to go with the step-by-step process. When you are multiplying each function factors, you should be careful. Okay. Then next problem is of determine the z transform of the sequence x of n is equals to, for n less than 0 you will be getting as 0, for n existing between 0 to 9 you will be getting as 1, when n is greater than 9 you will be getting as 0. From this, sketch the pole 0 locations and indicate the region of convergence. Therefore, the solution is going to be, before that you just draw the graph where is our signal is going to be existing. From 0 to 9, up to 9, you will be getting the samples from 0 to 9. It is shown. Therefore, then use the z transform equation, that is x of z is equals to summation n varying from minus into plus infinity x of n z power minus n. Our signal is going to be existing from 0 to 9 only. For that reason, our n is going to be from 0 to 9. What is the value of these all samples? It will be 1 only. For that reason, 1 into z raised to minus n. Here the formula is shown here, written here, that is n varying from 0 to n minus 1 alpha raised to n, you have to use the equation as 1 minus alpha raised to capital N divided by 1 minus alpha, with alpha is when alpha is not equal to 1. When alpha is equals to 1, you will be getting as capital N only. Here alpha is not going to be equals to 1. Here it is of z raised to minus 1 is there, right? Z raised to minus 1 whole power n I can write. Based on that, you have to write the equation. Then 1 minus, based on this equation, if I substitute 1 minus z raised to minus 1 whole power n minus 1, you'll be getting as n. Observe here, increment by 1. Here 9 is there, it means incremented by 1 position means 10 you will get. That is what here it is written. Then divide by 1 minus z raised to minus 1. Then solving this, and if I write the equation in terms of z, I'll be getting as, what you have to do for that, just you write 1 divided by z power 10 I can write, right? Here 1 divided by z I can write, take the LCM, do a small simplification, you will be getting as z raised to 10 minus 1 divided by z minus 1 into z raised to 9 you will be getting. Then where is our region of convergence is going to be existing? Observe here, ROC is going to be existing. All the z, whole z part is going to be existing, but except at z is equals to 0. It is not going to be existing. That's what the meaning. Then the number of zeros, the numerator part should be equals to 0. Z raised to 10 minus 1, it should be equal to 0. Then it will be getting as z raised to 10 is equals to 1 is nothing but 1 raised to 10 is nothing but 1 only, right? Therefore here it is shown the zeros. Observe here, 10 zeros surrounding on the circle, because the value what you got is 1. In its circle 10 zeros are going to be existing. That's what here it is shown. Then for poles, either z minus 1 is going to be equal to 0, as z raised to 9 is going to be equals to 0. Z minus 1 is equal to 0 means z is going to be equal to 1. Z raised to 9 is equal to 0 means zeros only. Here observe here, at 0, at a 0 only you will be getting as 9 poles. 9 poles are going to, you should not write mark as again and again 9 poles. No, one pole you draw and then show that here 9 poles are going to be existing. That is one part. And again z at z is equals to 1, one more pole. Observe here, 0 is also there, again one pole is also going to be existing. This is the z plane. This is one problem. And next problem is of find the z transform. X of n is equals to 3 into 4 by 5 power n minus 2 by 3 power 2n into u of n. Also find the region of convergence. Solution, it is given that given equation you write, then use your z transform equation, substitute for x of n. Then what is the limit is going to be changing for because of our u of n function. The limit is going to be changing from 0 to infinity. Then 3 into 4 by 5 power n minus 2 by 3 power 2n into z raised to minus n. Then z raised to minus n, for both the terms you have to multiply and have to take summation for both the terms. Then you will be getting the equation as 3 into summation n varying from 0 to infinity 4 by 5 power n z raised to minus n minus summation n varying from 0 to infinity 2 by 3 power 2n z raised to minus n. Then take the power in a common factor, that is 4 by 5 z inverse power n. Here 2 by 3 power 2 into z inverse power n. By using of the basic formula, use that, you will be getting as 3 into 1 divided by alpha. 1 minus alpha means 4 by 5 z inverse minus 1 divided by 1 minus 2 square 3 square 4 by 9 z raised to minus 1. Then separately it's taken as here 15z divided by 5z, 3 into 5. This 5 is taken LCM and taken to the numerator part. Then we will be getting as 15z divided by 5z minus 4. Here minus 9z divided by 9z minus 4. To find the region of convergence, where you have to go? After substitution of the equation. This equation you have to take. Therefore, 4 by 5 z inverse is less than 1. Then 4 by 9 z inverse is less than 1. Then you will be getting as mod of z is greater than 4 by 5 and mod of z is greater than 4 by 9. Almost it's z is greater for both the values. From these two values, which one is greater? That you have to check. That is going to be 4 by 5 is greater compared to the 4 by 9. Small fractional values are going to, you will be getting off. Okay, then you have to consider 4 by 5. Therefore, our region of convergence, the unit circle is going to be having the magnitude of 4 by 5. And our region of convergence, that is z, is going to be existing. It is greater value. For that reason, outside the circle it is going to be existing. This is what the equation. Okay, next problem is of determine the z transform of the sequence x of n is equals to alpha raised to mod of n, where mod of alpha is less than 1. What is its ROC? We have to find out. Given equation is x of n, alpha raised to mod of n. Our x of n is, because of mod n means it's going to be existing for both the positive values and also for the negative values. For that reason, when you are going to consider extending the equation for alpha, you have to consider for the negative values and also of the positive values. Therefore, x of n is going to be alpha raised to n u of n, where it is only for the positive part. Then you have to take the negative part also. From 0 to infinity, it's going to go off. From minus 1 to, I round the signal for continuous, it should be in a discrete, okay. From 0 to infinity, it is going to be, already 0 term is taken. For that reason, from minus 1 to minus infinity, you have to take. What is the equation I can write for this? It is nothing but u power minus n minus 1. You already done with some problems based on this, how you will be getting this, okay. Then alpha raised to minus n, keep this mind. If you don't write plus 10, if you write plus 10, it's going to be positive values. For that reason, keep your I, that is you should take as alpha raised to minus n. Then what you have to do? We have to substitute for x of n equation. I use the z transform equation. X of z is equals to summation n varying from minus into plus into x of n z raised to minus n. Then substitute for x of n value here. Here it is substituted and multiply z inverse for both the terms and then take the summation for both. Then solve for this. You will be getting as summation n varying from 0 to infinity alpha raised to n z raised to minus n plus summation n varying from minus into to minus 1 alpha raised to minus n z raised to minus n you will get. Then here take the power in terms of a common alpha into z raised to minus 1 power n. Here alpha inverse z inverse power n. Then what you have to do? We have to change the limit here. Here it is not needed. Here it is needed. For that reason, n varying from 1 to infinity. If I change the limit, our power is going to be changing. What I can do? Inverse is there. Minus 1 into minus 1 plus 1 minus into minus 1 plus 1. So I can write as alpha into z power n. Then use your basic equation. Then you will be getting as 1 divided by 1 minus alpha z inverse plus here alpha z divided by 1 minus alpha z you will be getting. Then take the LCM, do the cross multiplication. Then you will be getting as, solve for this. Then you will be getting as 1 minus alpha square divided by the denominator part as it is. Then x of z contains two sums. This is one and this is one, two sums. Both the sums should converge for the x of z to exist. For that reason, what we have to go use this equation. From that, alpha z inverse less than 1 and then alpha z is less than 1. Therefore, what I can write, mod of alpha is greater than alpha and mod of z is less than 1 by alpha. From this, I can write that our region of convergence is going to be existing mod of z in between alpha and 1 by alpha. This is what the conclusion we can do for this. It's a general equation where the problems, if it is given as a mod of some values, if in the general, like this is like a general equation, alpha they may give as 3 and power n they may give as 2. What you have to do, where is alpha is there you have to substitute the equation. It's like a general equation, okay. Substitute that, then what is our n is different. Here n is going to be changing from -2 to +2. It's not going to be varying from minus into plus infinity, okay. Based on that, you have to solve the problem, okay.